Some celestial wonders are so bizarre they make our classic idea of a star feel primitive, and the final entry will completely shatter what you thought was possible. Stay tuned until we reach number 1. Quasar 3C273 blazes a trail of energy that outshines entire galaxies, delivering more light than a trillion suns combined. Discovered in 1963, it sits about 2.4 billion light-years away, yet its radio jets pierce the intergalactic medium at nearly light speed, sculpting colossal lobes visible across the electromagnetic spectrum. Researchers estimate its central supermassive black hole weighs roughly 800 million solar masses, feeding on surrounding gas with an efficiency that dwarfs ordinary stellar processes. What makes this object truly mind-blowing is its variability. Its brightness flickers over days, hinting at turbulent accretion flows near the event horizon. By studying 3C273, astronomers gain a window into how early galaxies grew, how black holes power jets, and why some distant points of light can masquerade as stars in older telescopic surveys.
Pulsar PSR B1257+12 spins like a cosmic lighthouse, flashing radio beams every 6.2 milliseconds while harboring a planetary system that challenges the notion of where worlds can form. Discovered in 1992, this millisecond pulsar carries 3 rocky planets, sometimes called the first exoplanets, each roughly Earth mass, orbiting within a fraction of an astronomical unit. The extreme environment, bathed in intense radiation and magnetic fields, would seem hostile, yet the planets survived the supernova that birthed the pulsar. Their existence suggests that planet formation can occur from the debris of stellar death, a concept that reshaped exoplanet studies. Moreover, timing the pulsar's pulses with extraordinary precision reveals minute orbital wobbles, allowing scientists to measure planet masses down to a few percent. This system illustrates how stellar remnants can still nurture complex structures, expanding our imagination of planetary diversity across the galaxy.
Magnetar SGR 180620 unleashes magnetic fields 1,000 trillion times stronger than Earth's, making it one of the most extreme objects known. In December 2004 it produced a giant flare that, for a brief instant, outshone the entire Milky Way in gamma rays, an event detectable even on Earth despite the star being 50,000 light-years away. The flare released as much energy in 0.2 seconds as the Sun emits over 150,000 years, according to estimates. Such bursts arise when the star's twisted magnetic field suddenly reconfigures, snapping like a strained rubber band and sending shockwaves through its crust. Though the magnetar itself is only about 1.4 times the mass of the Sun, its radius is comparable to a city, packing that colossal magnetic power into a tiny sphere. Observations of SGR 180620 help astrophysicists probe quantum electrodynamics under conditions unattainable in laboratories, and they hint at mechanisms that could power mysterious fast radio bursts.
Supernova SN 2006 GY dazzled astronomers as one of the most luminous stellar explosions ever recorded, radiating the equivalent of 10 billion suns for months. Occurring in the galaxy NGC 1260 about 240 million light-years away, its brightness exceeded typical Type II supernovae by a factor of 10, prompting scientists to label it a superluminous supernova. The leading explanation involves a massive star, perhaps over 100 solar masses, undergoing a violent collision with dense shells of material it expelled earlier, a process called a pulsational parainstability. This interaction converts kinetic energy into light with astonishing efficiency. Estimates suggest the explosion released roughly 10 superscript 2 ergs of energy, rivaling the total output of a normal supernova over 1,000 years. Studying SN 2006 GY provides clues about the life cycles of the universe's most massive stars and the chemical enrichment that seeds future generations of stars and planets.
Black hole at the center of galaxy M87 became the first supermassive black hole ever imaged, revealing a bright ring of glowing plasma swirling around an invisible abyss. The Event Horizon Telescope captured this landmark picture in 2019, showing a shadow roughly 40 billion kilometers across, about 2.5 times the distance between Earth and the Sun, weighing an estimated 6.5 billion solar masses. This monster devours surrounding gas, heating it to extreme temperatures and launching relativistic jets that extend thousands of light-years into intergalactic space. The image confirmed predictions of Einstein's general relativity in the strongest gravitational fields accessible to observation. Moreover, the data helped refine models of accretion dynamics, jet formation, and the role such giants play in regulating star formation across their host galaxies. The M87 black hole stands as a vivid reminder that the darkest objects can also be the most illuminating for physics.
White dwarf BPM 37093, nicknamed the Diamond Star, boasts a core of crystallized carbon and oxygen so dense it resembles a massive gemstone floating in space. Cooling over billions of years, this stellar remnant, located about 50 light-years away, has solidified about 90% of its interior into a crystalline lattice, a process akin to a diamond forming under extreme pressure. The star's mass, roughly 1.1 times that of the Sun, is packed into a sphere only Earth-sized, giving it a density of about 1 million grams per cubic centimeter. Astronomers detect the crystallization through subtle changes in its pulsation periods, a technique called astroseismology. This discovery confirmed theoretical predictions that many white dwarfs eventually become giant cosmic diamonds. Understanding such transitions helps refine models of stellar evolution and the ultimate fate of Sun-like stars, showing that even in death, stars can produce some of the universe's most exquisite structures.
Neutron star PSR B1257+12 AD spins at a staggering 716 times per second, making it the fastest rotating pulsar known to date. Discovered in the globular cluster Terzan 5, this compact object packs about 1.4 solar masses into a sphere merely 20 kilometers across, yet its surface races around its axis in just 1.4 milliseconds. Such extreme rotation challenges our understanding of the limits of neutron star matter, as the centrifugal force pushes the star near the brink of structural breakup. The precise timing of its radio pulses allows astronomers to test theories of dense nuclear physics and general relativity under conditions impossible to replicate on Earth. Moreover, its rapid spin generates a powerful magnetic field that beams radiation like a lighthouse, sweeping across Earth every few milliseconds. Studying PSR B1257+12 AD offers a rare laboratory for probing the behavior of matter at supernuclear densities and the physics governing the most compact stars.
Hypergiant VY Canis Majoris looms as one of the largest known stars, its radius extending out to about 1,400 times that of the Sun, large enough to engulf the orbit of Jupiter if placed at the center of our solar system. This red supergiant, located roughly 3,900 light-years away, is in a late evolutionary stage, shedding mass through powerful stellar winds that create a chaotic, dusty envelope visible in infrared images. Its surface temperature hovers around 3,500 Kelvin, giving it a deep reddish hue, while its luminosity exceeds the Sun's by roughly 300,000 times. The star's erratic brightness variations hint at massive convective cells and violent eruptions that may presage an imminent supernova. Observations of VYCMA help astronomers understand how massive stars lose material, enrich the interstellar medium with heavy elements, and ultimately end their lives in spectacular explosions that seed future generations of stars and planets.
We've journeyed through a gallery of the universe's most astonishing creations, from blinding quasars to the enigmatic fast radio bursts that still puzzle scientists. Each of these objects stretches the limits of what a star can be, reminding us that the cosmos is far richer and stranger than any textbook can capture. If you enjoyed this deep dive, hit the like button and subscribe so you don't miss the next mind-blowing list that drops every week. Finally, tell me in the comments which phenomenon left you the biggest impression. Was it the diamond-like white dwarf or the ultra-fast neutron star? Thanks for watching, and keep looking up.